Hello everyone, I'm Muhammad Hazrin. Will present a research on hybrid multilayer perceptron network for explosion blast predictions. This research has been done together with Dr. Fakhur Ridwan Hashim, Mr. Jafar Adnan, Mr. Muhammad Shahril Saleh, Mr. Khalid Isa, and Major Prakash Nagapan. This research comes with a question of why do we need to switch to other explosive rather than existing one in military training. It is because currently military in Malaysia spend high costs on explosive as it is imported from United Kingdom. The price also high as not easy to find supplier for explosive material, especially for military uses. The, Therefore, the objective of this research is to analyze the performance of PE4 explosive from database and experimental tests in tropical environments. Secondly, it is also to investigate the equivalence between PE4 performance in tropical environment and emulate explosive performance. Finally, this research is to design the prediction model by using artificial neural network. The scope of research focused on the development, formulation of PE4 and emulate equivalence. It is also to determine the blast parameter through a field blast testing, and more to carry out the modeling process using MATLAB. This research really significant to develop the PE4 and emulate equivalent models. It will help the users in defense and security applications by reduce the cost of explosive used during training. Our military also will have the better knowledge in explosive as they can increase the number of training in their futures. There are a few related work and theories have been made in this scope of artificial neural networks that focus more on the technique of network classifier, which is multi-layer perceptron network, and able to make good theories on artificial neural network for blast parameter predictions. Based on Chang on his research on deep and shadow architecture of multilayer neural network, ANN is a machine or software that has the ability like human intelligence. It can provide with problem solving in terms of pattern recognitions, control, and clusterings. Chetri R and P really also add that artificial neural network actually have features or ability to learn the solution a problem from a set of data or examples. By these two theories, it's shown that artificial neural network have a great ability to reduce the test to get a set of data. Instead, it will learn how to predict the data pattern. In the Journal of Shockwave by Claire, K, and Nigel, they mentioned that MLP or multilayer perceptron suit to use as a prediction tools, and RBF network technique more toward clustering a set of data. This is made more concrete to use MLP technique as a prediction network tools. However, based on Heiken on 2011, MLP will work as nonlinear neural neuron model where a sum process at all the multiplier signal or input as a bias, and the result is sent to the activation function. This activation function will predict the output product. Therefore, there have been several modified versions based on conventional multilayer perceptron network, such as the addition of nonlinear connection direct from the input layer to the output layer to form a new network known as hybrid multilayer perceptron network. The dashed line show how HMLP network works. Based on mature HMLP network could improve the accuracy of result compared to conventional MLP network by have a direct connection between input and output data. However, training algorithm will have a higher responsibility to ensure the accuracy will be at the optimum. For blast parameter predictions, routine training on explosive testing is carried out periodically based on shape, weight of explosion, and distance from sensor to explosion work as an indicator. The blast performance is measured as a peak over pressure in MPa. By having this, we can stimulate the tropical corrections ratio between PE4 database and PE4 experimental results. By doing this in tropical climates, we also can stimulate the PE4 experimental result and emulate correction ratio. Based on the finding that recorded in the explosive testing, we have testing a few type of shape. The data shown here is cylindrical shape charts by using emulates. We have a peak over pressure over here from 0 to 4.5, and we have a distance in meter from 0 to 5. We will stop the result at a 4 because when it more than 4 meter, it will be 0 peak over pressure. The optimum result for peak over pressure is at a 0.5 meter, and if we can see here, when we put the detonation at the top, center, and bottom, it will be different in the peak over pressure. So the best will be at the top for cylindrical shape. The finding of explosive tests conducted in the tropical are shown in table above. In comparison to the manufactured data, the acquired result clearly illustrate that the tropical action reduced the pressure of PE4 immediately. The correction ratio to be divided by the manufactured data reading according to table 1 was in the range of 1.15 to 1.22, and it will reduce dramatically to 1.18. And this is the PE4 equivalent ratio of PE4 to MULEX in MPa. This table compares the explosion produced by PE4 to those produced by MULEX. When the PE4 MULEX ratio was calculated, it shown that PE4 had a large explosive effect than MULEX, ranging from 1.28 to 1.42. By having this data, the training in military, they can use Amulex as a replacement to the PE4. So this is the mean square error and regression performance of HMLP networks. This table also shows the training algorithm that we use in this research. The table above shows that the BR training approach has the best MSE performance for the MLP network with mean square error of 0.0079 compared to others that have more mean square error. The MLP network trained with LM and BP obtained the second and the last. The Bayesian regression training algorithm is capable of giving the highest regression reading of 0.111, 0.9991. The BR training algorithm outperforms the LM and BP training algorithm when it's come to MLP network. Since the explosive tests are being conducted in tropical environment, the PE4 adjustment ratio must be used. Furthermore, the PE4 emulate ratio was divided in order to compute the exact weight of emulate required to equal PE4 during an explosive test. The hybrid multilayer perceptron network capability to forecast the explosive dataset in the demonstrated by the network prediction result. The accuracy displayed by the Bayesian regression training algorithm is the best, with the minimum mean square error and the best regression performance. According to the data, the MLP network accepts the type of explosive, the distance of explosive effect, and the shape of explosive as perfect input. The main purpose of the study is to find the best algorithm to use as the brain of the blast prediction models. So this is the blast prediction system that we designed by using MATLAB. We will have a train network button here, so when we have the input data, we can train the data over here using hybrid multilayer perceptron networks. And we can choose the type of explosive here, which is PE4 and Amulex. After that, we also can change the shape of the explosive, whether it's sphere, cylindrical, or hemisphere. So we also can see the distance of the sensor to detect the peak over pressure. So when we click the perform button, the peak over pressure we will calculate based on the input that we provide here. Thanks for your listen. Thank you.